going to be graphing this. You're going to locate, there's no directrix in this, just the foci points, because there's no place to put a directrix line. Just your center and your foci are going to be important. And the foci is the distance from your vertex to the point, is from the C is the distance from here to here. We'll go over that when we start doing these. The difference between the horizontal axis and the vertical axis is just the way that your ellipse is shaped. So if your ellipse is shaped longer lengthwise like this, it has a horizontal axis. That's a major axis, whichever one is longer. And your axis, again, just like your circles, having your centers all offset, it's just translated. Your vertical one means this. The oblong is this way. So it hits a vertical axis instead. And they can fall in the center. They can fall like this too. They can fall there. Sometimes they fall, they almost look like circles because their pieces are so close. What drives this, major versus minor, is this right here. A is the major axis. So when we identify an ellipse and we set it up as an ellipse formula, we'll take the larger number in the denominator, and that will be A. Because the larger number will make it longer than the other one. If they were both 3, they would be a circle. If one is, say this is 16, these are also, so this would be A squared, this would be B squared, this would be my longer one. So instead of being a circle, I'd be a little bit longer this way. Sorry, this way. Nope, this way. I'm not a very good spatial person. I have to use the numbers. Okay, it will be a little bit longer that way, going off the x-axis. If it's a vertical, it'll be a little bit longer this way. That's what gives you the elliptical part of this. We're still going to complete the square. We're going to get it set up like this. It's going to look like a circle with a denominator. And then we're going to talk about all the pieces for it. Good? Okay. These are not so bad. Did you see any ellipses last year? No. All right. So we're going to sketch this guy. We're first going to identify it as an ellipse. What makes it an ellipse is this. What makes it a parabola is only one square. A circle, ellipse, a hyperbola have 2 squares. What makes the ellipse different is the number, the coefficient in front of these x and y's, and the fact that it's a plus in between. So a plus to give us a circle or an ellipse, but the fact that my coefficients are different will give us an ellipse. We don't have to see it right away. We just have to realize that it's not a parabola. It could be a circle right now, or it could be an ellipse, because I have a plus in between. And they're both on the same side. If they're on separate sides, don't forget, we're going to move one over. So set this up so that you're going to complete the square. Set your x's together and leave a space. And then do the same with your y's, because you got to complete the square. Move this 9 over here. Take the opposite and move it over. Eventually, we want that side equal to 1. Unless it's a circle, we can leave it. Since we added twice, we're going to add twice here. Good so far? These are a little bit different because these have coefficients in front of them. And with your coefficients, we're going to have to factor out your leading coefficient. But that's okay. When we do this later, we're going to divide by it. And we're going to get rid of those coefficients. Again, they're going to fall into this category. It's got a plus. A y, h, and k never change. The h always goes with the x. The k always goes with the y. These are interchangeable down here. depending on which one is the major vertex. The A will always be the major. So now we complete the square. What's half of 6? 3. What's 3 squared? 9. 9. 9. Now, to do the y, you have to factor out the 4 first. This leading coefficient has to be 1. So factor it out. So now, we're okay with that, right? Completing the square. So what's half of negative 2? Negative 1. We're going to bring down this 4. Now, what is 1 squared? 1. So if I put the 1 over here, I can't get it out of that parentheses until I distribute this. So I'm technically adding a what to this? A 4. Now, all your pieces are there. This will cancel this out. This will be a 4. It can never be equal to a negative. If it's equal to a negative, then we probably have a hyperbola. An ellipse cannot be equal to a negative. Because both of those signs, I should take that back. If both of these signs were negative, then we could divide by a negative. But it can never come out to be a negative. Now, your goal is to get that to be a 1. Because you can see these coefficients are not the same, right? So there's not, so it looked like a circle, almost a setup of a circle, but these coefficients were not 1. When they're not the same, it's an ellipse. So this has to be equal to 1. So divide everybody by whatever this thing is down here. And leave it as a fraction. Just keep that one with the 1. Okay. So which one's bigger, 4 or 1? 4. So assign A to 4. Make a little chart out here. A, B, C. So what's A? 2. Easy way to remember this is, see the top is squared, the bottom is squared also. So you've got to take the square root. One of the mistakes I see all the time is when these numbers, especially if they're not perfect squares, like if it's a 3 and a 1, a lot of kids give me 3 and 1. Remember, the top is squared, the bottom is squared. And we can get radicals in this too. So we take the square root. So A is 2. What's the square root of 1? 1. So then we're going to use C squared is equal to A squared minus B squared. C is going to give us where our foci. So we're going to put in 4. Just take this right from here. And so C is going to be radical 3. And we can have radicals in this. We do get a lot of radicals as an example. All right. So we're going to sketch. So start with your vertex. What's your vertex? Good. So negative 3, 1. Now, what I find helps me, I told you I'm not a very good spatial person. Sometimes I just go like this. So now I can count better. All right. Now, is it going to be the major axis be the x-axis or the y-axis? The x, because that's the bigger. That's what's under the x has the bigger number underneath it. So like that. So now, this is going to move over 2 and over 2. So if this is a negative 3, you just have to get your spacing right. If this is a negative 3, 2 is going to put me over here. 2 is going to put me over here. These are my vertices. This is my center. Sorry, I called it a vertex. That's my center. These are my vertices. They come off of the main axis. So all you got to do, instead of worrying about the formula, is the same thing we did with the parabola. Slide it over. So if I take 2 away from here, what's that point? If I move this 2 to the right. Okay? If I move this 2 to the left. Okay, negative 5, 1. So I've got my vertices. My co-vertices are on my minor axis. So that's where my B comes from. So I go up 1 and I go down 1. Now look where I am. If I go down 1, I'm here right on my axis. My sketches are always terrible with an ellipse. I apologize. So we call these your co-vertices. And again, rather than worry about your formula, just say if I go up, if I'm changing my x and my y when I go up and down, my y. So it's going to stay at negative 3. I'm going to go up 1, so it's going to be negative 3, 2. I'm going down 1, so it's going to be negative 3, 0. So your ellipse is going to look like this. Terrible ellipse, I'm sorry. It's got a touch down here. This is really bad. I can't draw for beams. Now, your foci come on your major axis in here somewhere. This is where your foci is. Your foci are inside the ellipse, equal distance from the center. This is right where C comes from, right here. This is C. My board's off right now. I gotta reset my board. My board is just not drawing where I want it to draw. But your C is the distance from the center to your foci. That's where your radical 3 comes in. So start with your center and do the same thing that you did with your vertex. You took your center, negative 3, 1, and you added and subtracted the 2. Now you're going to add and subtract radical 3. So technically, I take, and I can't really do it with a radical, negative 3. I'm going to add radical 3 to it. So it's going to move me over, and I get what was my 1. And my other foci is negative 3 minus this 1. If it turns out you can't simplify this, you can leave it like this.
So C is from the center to the foci.
To the foci. From the center to the foci. Now, watch up here for 1 second. If you want A is going to be the bigger number, right? B is the smaller number. If I square those, which are these right here, and I added them, then I'm going to come out outside of my ellipse. So our goal is we take them, we subtract them, which is where you get this formula from. So it keeps me inside my ellipse. Now when we do a hyperbola, it's like 2 little parabolas, we're going to be outside of the ellipse. You'll see the difference. But these guys, we're subtracting these, the squares, staying inside the ellipse. We want our focus points to be right alongside, on the major axis, right alongside the center. Make sense? So those are the parts of your ellipse. Your major axis is your x, your co-vertices, your center, your vertices, your foci. That's your ellipse. And before I do anything else, I'm just going to reset this board for a second. Try another one. All right. All right, let's try another one. This is in standard form. This is that big long ax squared with the bx squared, the y squared, and all those other things, e's, d's, f's. This is your standard form. So we look at this. Could this be a parabola? No. Why, Grant? It's got an x and y squared. So right away I know it's not a parabola. So the only other ones we learn, ellipse, hyperbola, and circle, that you know and love. So could this be a circle? No. Why, Bob? Your coefficients are different. Everything's on one side right now, but your coefficients are different. So if it's not a circle, it's an ellipse. That's what makes one side longer than the other. Do you guys do elliptical paths in science? You did? Did any of it look like this at all?
Like we didn't use anything with like equate
No equations.
and we just did cycle through the acceleration and stuff.
Oh, okay. Velocities.
Yeah.
Yeah. Okay.
It'd be a hard pattern.
Yeah. But yeah, that's as far as you guys go with the elliptical patterns? Okay. We do that with parametrics, but I thought you did something with ellipse. So we identified this as an ellipse. So we're going to get our x's together. And we're going to put our y's together. So we can complete the square. Our constant, take the opposite, move it to the other side. Right, again, we're going to have to factor this out. So we need a leading coefficient of 1. So go to the top part. What's half of -2? -1. And what's -1 squared? 1. So to come out of the parentheses, I have to multiply. So if I add 4 here, I have to go over here and add 4. I have to bring this 4 down with me. Then we do complete the square over here. What's half of 4? 2. What's 2 squared? 4. Add 4. Now the nice part is when the other side works out as a perfect square, or something divisible into these. When it's not, we end up with fractions, but right now we'll work what we have. We know this is an ellipse. We determined it was an ellipse, so it has to be equal to 1. So we're going to divide everything by 16. These have to be able to factor, or we're going to move our fraction around, and we'll see that later. So here's our equation of an ellipse. So start A, B, C. So what's A? Who's that for? 4. I heard a 4. Good. Because A is the larger number. So square root of 16, 4. What's the square root of 4? 2. So this guy, just leave them in your squares. 16 minus 4 is 12. Just reduce that. So 4, so it'll be 2 radical 3. Just make sure you keep all your fractions reduced, all your radicals reduced. Alright, so next, let's graph it. What's my center? Good. Regardless of where your major axis is, x still always goes with the h, regardless of where it falls out. These are also interchangeable, so don't let that sometimes fool you. Sometimes they put the y² term first, which doesn't change your ellipse because this is commutative property. So it doesn't matter who comes first. Sometimes, God bless you, you're going to see the y come first. Because commutative property says I could add in any order. What makes the difference is the bottom number, the denominator. Whichever denominator is larger is your major axis. So my major axis is going to be a vertical or a horizontal? Vertical. So it's going to go this way, looking like this. Okay? Oh, wow, that's really perfect too. Okay. So my center is 1, -2. If it helps you again, draw an axis. Just translate your axis. It makes life a little easier. Okay? So I get I'm going this way, so I'm going to do A. A says go up 4, go down 4. We got the 4 from here, A, B, and C. We took the denominator of the larger one, that was our A². So the first thing we do is square root everything. And over the years of doing this, I see kids a lot not take the square roots. When it's 16, they usually do when it's 16, but like a 4 and a 5 or a 4 and a 9, they forget. All right, so these are my vertices. So give me a vertice. 1, 2. Good. See, you guys are doing it without the formulas. Much easier. It's the same with that H plus P plus C, whatever we're doing here, plus A. You have them all over the place. Much easier without. Okay, let's get a covertice. My B is 1 up 4 and my B is 2. Now, if I go down here, this is at a 1. 2 is going to put me over here, and 2 is going to put me over here. So what's a covertice? 3, negative 2, and negative 1, negative 2. So my ellipse is going to go like this. I'm going to make you do it up here. It's so hard to draw up here as it is. So hard to draw. I figured out how to erase. Try it better. This is the one thing I hate drawing these. I'm better at the hyperbola. Okay. So now I need a foci point. My foci is going to be on which axis? My vertical or my horizontal? Vertical. It always goes on your major axis. So I'm going to go up to radical 3. Now, my hard part is, where do I put this thing? So I estimate. Radical 3 is a little bigger than 1, a little less than 2. So a little bigger than 1 times 2 puts me a little bit bigger than 2. So I just need to know, am I under this or over this? So I'm a little bit over, and then this one I can kind of space over here. Just kind of estimate. So my foci, again, since it's a radical, you can just take, you're going to change the y part. You can just leave the x here and do the y plus or minus 2 radical 3.
It would be the same.
Well, it's one is add 2 radical 3, one is subtract 2 radical 3.
But don't you add it to negative?
Yes. So you could kind of combine them if you like. If you do them out, you really can't resolve this, so you could say plus 2 radical 3, and then you can say 1, negative 2, minus 2 radical 3. So if you like, you can just combine them into 1. Because there's no way we can reduce that down. That's your ellipse. Okay. Major point again is you're going to complete the square. You're going to recognize it as an ellipse. It's got an x squared and a y squared, but their coefficients are not the same. We want to set it up like a circle, start like a circle. That's how we started, like a circle. But then we just divided everything so that we could set it equal to 1. Once it's set to 1, it's now an ellipse. And a circle is a special ellipse. If both of these coefficients were the same, we could either leave it as a circle or we could leave it as an ellipse. What would happen is A and B would be exactly the same. So it would go up 3, over 3, down 3, left 3. So it would do the same thing. It would still give you a circle. Okay. You want to make sure your major axis is your A. That's important. So know which way your ellipse is going to go. Your foci is going to sit on your major axis. Again, this piece, really, really important. Make sure you put the A squared down there so that when you come down here, you take the square roots of everything. It's a little noticeable when these are perfect squares. It's not as noticeable when they're not perfect squares. If I did this, don't forget to take the square roots. That'd be radical 5a, radical 3b. And c would be radical 2. They could all be radicals. So even though they don't look like perfect squares, don't forget to take the square root. Set your center up and slide your focus off your major axis, your vertices, your co-vertices. Again, if you like the formulas, I gave you the formulas. The formulas, you got to keep changing A and B. Worry about are you adding to H or to K. So you might as well do it without the formula. And then you don't have to memorize it. And that's it. That's all there is to an ellipse. They sound scarier than they look.